Ready to go? All right. Thanks, everyone. Appreciate you joining. Hope you're enjoying your time at Big Data London and enjoying the show, especially for those that traveled all over to be here. My name's Mark Lyons, and I'm joined by Jonny Dixon. We're both from Dremio, so nice to meet you all. Today we're going to talk about kind of open standards and what's happening with open lakehouses, and Jonny's going to bring us through a very concrete example of building a lakehouse and bringing data into a data lakehouse. So on with the show. I just want to set the stage kind of before we jump into the details here and Jonny walks us through kind of the architectural shifts that have happened over the years in this data management space. So, we started with kind of traditional data warehouses and Hadoop systems where storage and compute were directly attached, mostly on-prem systems. That spawned a wave of cloud computing. Amazon, Google, all the cloud systems came up, and that was where we separated compute and storage, right? And all these systems became very scalable, the warehouses became very scalable, and everyone started using S3 or object storage as like the primary data storage for the system. And that alleviated a lot of concerns around scalability, being able to scale storage separate from compute. But you're still loading data into these systems, and they're kind of single engine systems where once the data's in, that it's only that engine that can access the data. So the next evolution of these data management systems is separating the data tier from the compute and storage so that they can be multi-engine systems. So that's kind of the big benefit, and the concept of a data lakehouse is getting the data tier separated so we can have multiple engines, SQL engines, Spark engines, Flink engines, Python, whatever folks need, all operating on the same tables, the same data, whether these are raw, kind of uncurated or very curated tables of data. You're getting a benefit of not moving the data. All the teams, different consumers, different skill sets, all are still using the same data. We're not building cubes, we're not moving data to data marts, other warehouses. And this is just going to be kind of the next architectural shift and very efficient use of money, time, resources, and data. So, I'm very excited, having spent a while in this space, to see this transition where customers won't be thinking about, hey, there's a new tool, I have to migrate my data, unload it from this system, load it into the next system to hopefully get more performance, and then do it again and do it again. So this data lakehouse concept, I think, is a very powerful concept in the industry, and the table formats are kind of the pillar of that. So I'm going to turn it over to Jonny. I want to thank everyone for your time, and Jonny's going to kind of walk through a concrete example of building a lakehouse.
Sweet. Hello, everyone. And for the people, I suppose what I'll probably do is microphone back here, but then I'll speak a bit louder so people who don't have headphones can hopefully hear me. People who've got the headphones, all good? Good sound? You want it closer? Okay, closer. So, but tell me if I'm too loud, people in the headphones. So what I did last year, and I apologize, I have a tendency to roam while presenting, and I tend to be a bit deadpan as well, so there'll be some jokes that probably get no laughs. That's fine, that's intended. What we're actually going to do is pick up from where we left off last year. So if you missed last year, bad luck. It was a great talk. People to stop me on the street months afterwards and say, I remember that Big Data London talk. I mean, that's just what other people tell me. I don't say it about myself. So what we started off with last year is we looked at an architecture of where we're going to start out with how we remove things like our data warehouses to go from really the architecture where we have here, where we're using Spark and other kind of best-of-breed engines to do our ETL, through our landing, standardized, and curated zone. And we looked a bit at how we then take that to be on top of the data lake directly, rather than pushing it into a data warehouse, but actually querying that in situ. Now, what we're really going to look at today is a bit more of a concrete example, looking directly at really the biggest problem I see out there, which is we're on-prem today, we've got databases, we've got data warehouses. Great, you talk about the data lake, but how do we actually get the data there? So oddly today, I'm going to speak not that much about Dremio at all. We're actually going to be speaking about other tools in order to achieve this, to get you to that path of being in the cloud data lake, or even an on-prem data lake if you're using Minio or something of that ilk. what we're going to do first is we're going to take this step by step. If we look furthest back, we've got our data in our database. First thing we're going to need to do is, hey, we need to get that out, and we need to track all of the changes. And I probably won't be the only person who talks about this over these 2 days, but I've definitely seen a big rise in Debezium. Now, people might be asking, what is Debezium? Hey, I've never heard of Debezium. Tell me more. Well, at the bottom, we've got a nice little architecture which shows what people tend to be doing with Debezium. But basically, I've started off with a real simple, what is Debezium? You know, it's DBs, so from databases, Zium. And it's open source, and what it can act as is a CDC technology to sit on top of your Postgres, your MySQL, your Oracle, etc., and actually take that data out and push it somewhere else. You know, stuff like you might have with Oracle Streams or, like, say, Golden Gate, as you may have done in the past. But one important thing about Debezium is that it can work alongside our Kafka. So we can have Debezium hooked up to our via Kafka Connect in order to say, push this out to other locations. And you may say, hey, you've got Elastic, you've got your data warehouse, I don't see the data lake. Well, what we've seen in this being open source is we can extend things. So I've seen a huge amount of progress over the last number of years, and I'm taking credit for something I didn't do. This has been done more in the open source, about building an Iceberg connector. And that's why I would care about something like Debezium. So I can be sitting with proprietary storage today, where I've got my operational data source, and I can now very easily, just by hooking up Debezium, get this into my data lake in an Iceberg format. And for anyone who's not familiar with Iceberg, we'll talk about Iceberg in a second, if that's seeming somewhat unfamiliar. Now, it can also be therefore used for things like Dremio, where we get advantages out of it if there's certain things that maybe we don't support. You know, stuff like Vitesse, for example, or Cassandra, where we may say it's going to be slow if we go against that and actually query that in situ. What I've seen over the last number of years is people look at migration projects that really aren't instant. They take 12 to 18 months to get data out of relational sources. They happen with overnight batches. There's complex scripts. That's what makes things very difficult, is we have to work out all of the complex logic that we have in our existing systems in order to work out how we land it somewhere else. So in using a CDC, an open CDC process like Debezium with our Kafka, that then gives us a real nice way in which we can be independent of our operational source. So when looking at democratizing data, we can now get to that point where we say, we can extend this to as many people as we want. We're not going to take down a production system. We've got the data elsewhere, and also it's scalable. So we don't necessarily need to think, okay, how many use cases do I have now? I need to size my downstream engine for how everything's going to look in the future. Now, we'll jump also into where this kind of sits in our end architecture. So Mark touched briefly upon where we're looking at those changes in architectures. I'm going to confess, there are things that we had in the data warehouse world that are very good, that make our lives very simple. When we moved across to data lakes, we didn't necessarily have all of that. You know, dealing with transactions is very difficult, as well as storing all of the metadata and bringing that together in an entire catalog. So we're actually going to look at, well, okay, I've used Debezium to get the data out. You've said that there's this mythical Iceberg format, but how does that work with actually the queries that I want to run, the data sets that I want to create, the schema that I want to create in downstream of all of that? So we're going to have a look at kind of the ways in which we dealt with that. In the old world, if we had a directory, we created, say, partitions. Our table was effectively a list of all of those files. But along came Netflix, who started this mythical Iceberg project. And they had these goals. They wanted to have ACID transactions on S3. Sorry, I'm probably in the way of some of the people. They wanted to have ACID transactions on S3. They wanted to support table evolution, have correctness and consistency of that table. They wanted to really be able to optimize how we can plan queries, because you can effectively see if we've not got, say, the likes of the correct partitioning, etc., that actually is very complex to plan an efficient query. And we also want to decouple the partitioning from that layout and do that really at scale. When Netflix was starting out, they were looking really at petabyte scale, even on the table level. So what we want to do in the new way is actually do that decoupling. And within Iceberg, people familiar with Delta Lake say, hey, this looks very similar. Well, it is very similar. It's more open, but actually the approaches are somewhat consistent. If we dig down to a lower level, what we'll actually see is this is the layout of an Iceberg table. We're going to start off at the top with our table metadata file. And what that's really going to give us is, hey, what columns are in this data set? When was it last updated? And what's the kind of partitioning strategy around that? So that I've got that table level metadata. What's really handy about even this top level is no longer do we need to go out and discover metadata. Do we need to read files in order to make a consistent schema upon read? We've got a lot more of a structure that's actually defined. It can change over time, but what we'll see underneath that is that table metadata file will point to a manifest list. This is where things do start to change a little bit from Delta, because people may see, there's single levels in Delta where you've got your commit log, but in Iceberg we'll have these extra hierarchical files. Within my manifest list, it will list my manifests. So you might say, okay, well, what's a manifest? What a manifest will do is it's going to contain a list of all of the data files that I'm actually going to read. So then what that means is, as we perform updates, inserts, etc., we're going to be creating new Parquet files as part of my table. But I've also got a history of everything that's happened. So if I want to step back in time, well, I can read less of those files. The way I can read less of those files is I can go to the previous metadata file. Because it has the snapshot time, I've then always got that history. And that starts to bring some of those table concepts that people may be familiar with in Delta or even data warehousing out into the data lake. Because now we've got our full history. Great, we've done this on one table. What next? Well, what if we want to think of, say, different schemas that we have, different tables that we have across our entire catalog? That's why we in Dremio identified that this was a big problem, and so we created this thing called Project Nessie. Don't worry, Project Nessie is also completely open source. And what Project Nessie is going to do is it's going to act as your metastore, really above all of those transactional tables. Things like Hive weren't really built for transactional tables. They were really built to contain the partitions and the table levels. They weren't ever created to create the file level, whereas Nessie can start to hold that type of information for us. When we look at certain advantages that we wanted to bring with Project Nessie, what we really want to do is also give people that ability to step back in time, not just on one table, but on their entire schema. So I can say, how did my entire database look this time yesterday? What that brought along with it was certain advantages whereby what we could start doing is saying, I can now start to create different branches. And what's important about those different branches is then we can think of that gold, silver, bronze, or that maybe where we have even dev, UAT, prod, and actually say we no longer need to have separate environments where we create carbon copies of the data. So that ETL pipeline can be made a lot simpler. Great, so let's actually look at this in terms of an example. We may start out with our data lake without Nessie. It can sit on top of our can have our Iceberg, we can have our Delta, we can have our Parquet, etc. We would have these 3 independent tables: sales, inventory, customers. We've got single transactions, tables are somewhat unrelated, and we've got that linear history within each and every table. As I update data, okay, great, I've got a new version of that. But what does that mean when I'm looking at sales and my inventory together? I don't know. I have to work that all out. Now, when using Nessie, what we can actually start to say is we've got multiple table transactions. Things that actually happen across my entire lake, or across my entire, as we would think of it, really, database. And within that, what we can actually start to do is create those branches, as I mentioned. So I might say I want to experiment with the data. I want to test out how it may look if I transform it in a slightly different way. And then if that works, I can actually kick that into production. Great. So now where we are so far is we've got the data from our relational sources. We've started to be able to build that, as I'll call it, utopia, in the lake. We did that with Debezium. We started to land that in our Iceberg tables. So we've got our good storage format for our history. Within Nessie, we're looking at how we would actually add all of the meaning and how all of these tables are joined together, but that's not the end of the story. Great, I've got the data in. So what I'm going to actually look at is now from here, how do I go through and transform it? My data engineers, my people within operations, they need to perform transformation within the data. And if you're a Big Data London, you're not talking about DBT this year, then it seems as though you are very much in the minority. I would almost go as far to say, you're a loser if you're not talking about DBT. Everyone's talking about DBT. Everyone who we see on the stand is coming up saying, I'm using DBT. You'll find out on the next slide why I've kind of mentioned them. But one of the great things is if we're wanting to abstract away even the underlying technology around our transformation that we're actually looking to do, then DBT is going to be really useful for us here. What DBT is going to be is that it's going to be our T in our ELT. And what that's really going to allow us to do is say, I can now start to use any engine. What DBT is going to be is that thin layer on top of your underlying engine, giving you a way where you can write SQL in a consistent way and not have to think about underlying technologies, because DBT can be applied in multiple different places. So that we can create models across our data lake, our relational sources, all of that kind of good stuff in order to bring them together in one cohesive environment. Now, you probably know I work for Dremio, but I thought to be fair, I would say that, DBT comes in its 2 varieties. There's the free version, which I know a lot of people are using, and there is also extra things with, say, GitHub integration that comes with their cloud version, just to be fully transparent. Now, so where we see real things, why I should care, is because of exactly that one SQL syntax. We only have to learn things once. In the rise of big data over the last 10, 15 years, it seems as though every week you normally have to go and learn a new tool. And that's not very fun. So having something that we can remove that need, if we can remove that need, then that really gives us a lot of power. We can actually start thinking about how we use the data as opposed to what new tool am I learning this week. We can also test and track our changes. So this then becomes powerful alongside being able to create things like those branches, being able to sample with data, because we can test and track changes that happen throughout our DAG as well within DBT. One thing I will also mention around the best of breed technologies and why we love DBT, they are a Dremio partner. That's the most important thing. Otherwise, they wouldn't get a slide here. No slides. They have. So what we're actually looking at getting towards the end is, well, we've looked at bringing the data into the lake, transforming it, how I do that, how I store it. But at the end, this is going to be the Dremio plug. So apologies about this. what I'm going to now need to do is query that data. So I'm going to need my open lakehouse platform, very similar to what I talked about in that legendary talk last year. So we've got the likes of our storage in the cloud, and we still might have some data that lives in relational sources that we haven't migrated over yet. So what we're actually going to want to do is get value out of that. We've got the architecture. Now we've got the use cases that actually come up. We're going to have people who sit downstream who aren't a technical audience. They're perhaps people using dashboards for their daily reports. They're using data science perhaps if they are more technical, but they're less bothered about where the data is sitting and how it's stored, and more about how they get value out of it. Or it could even be custom applications that we have built on top of our lake. What we're actually looking at doing within using, say, Dremio alongside these other tools that we've talked about today is really how do I progress the pipeline from being weeks and months all the way down to days to really be able to start to get value from my valuable data. As much as I think we all like talking about technology and working with technology, at the end of the day, the most important thing is how productive we are. And so we all have timelines to hit, we all have results that we need to get. So being able to do that as quickly as possible and enable as much self-service as possible really makes this more and more scalable. So that's exactly what we're looking at doing. We're looking to provide these main 5 benefits. We're going to get that faster time to insight because we're no longer looking at long-haul ETL processes that take weeks, months, years in order to plan out all of the fragile parts of it. We're looking to make people on the technical side more productive and generally, hopefully, have less of a backlog than they have currently at the moment. We're going to be looking to make, and we're going to do that through making our end users more self-sufficient. So we're going to be looking at, as we have talked about today, planning out that architecture, but really what we're looking at doing at the end of the day is saying, let's take this away from full ownership of, let's say, the IT community, and that we can put it more in the hands of our end consumers. And always an important one, especially if there may, I feel as though the more you say that there might be a recession coming, the more likely it is. Everyone's going to need to reduce their costs over the next number of years. There's not as much cash around within organizations as there used to be, so we need to look at streamlining a number of those processes and reducing our infrastructure cost. And we can actually do that through reducing complexity. We weren't going to look then at now getting towards our flexible open architecture. So to recap, where have we ended up? We started out, here we go. We started out here. This was the utopia. Today, what we've really looked at is how can I take these application databases, these CDC tools, and actually put a name to this very general topic. So we've started to say, let's put in a Debezium. Let's do that CDC. Let's get that into our lake. Let's store that in an Iceberg format so that we've got our transactions that happen. Let's also put in an open metastore like Project Nessie so that we can start to track our changes going across multiple tables. Let's orchestrate a lot of this transformation using a DBT. And then this is the most important bit. If there's one thing to take away, this is the thing. Then you want this interactive data lake engine. This is the one right here. It's the money shot. It's using open data lake, open lakehouse query engines like Dremio in order to get value for our data science platforms, our SQL clients, our BI tools, our custom applications. So I've been Jonny Dixon. You've been a great audience. I'm going to pass it back to Mr. Mark Lyons to finish us off. But thank you, everyone.
Yeah. Thank you, Jonny.